Hello, and welcome to UFO Optics, a citizen science project to scan and detect flying craft from satellite imagery. I'm Mark, and I started UFO Optics from a post in Reddit about a week ago after the congressional hearings in excitement, frustration, um, excited that a lot of information is coming up, but also frustration that we haven't got any hard evidence, as I'm sure a lot of people are. My background is in software engineering, and I've worked on projects before with geospatial and satellite imagery. So it occurred to me that a project like this is something we can do as a citizen science project to look at the satellite imagery that's out there, to focus on detecting flying craft from satellite imagery. I'll start with reiterating that the focus of this project is to detect flying craft from satellite imagery. The UFO UAP world has a lot of topics, a lot of interesting things to talk about, but the focus of UFO optics is that. Um, Otherwise, I'll dive right into it. This is going to be an overview, an introduction, hopefully orientate you if you're interested in the project and what our goals are and what our methods are, and then hopefully you can jump on board and contribute and be a part of it. Alright, so this is an overview of the system as a whole. On the left hand side we have our source imagery. This is the images that come off the satellite. In the middle we have processing. This is scanning the images, and on the right we have detections, which is our database of recorded objects of interest that we've detected in the images through one of the processing methods. The processing methods are broken down into three categories. So visual is the manual processing, or human processing if you like. So that's just panning around the satellite imagery um, ourselves and recording objects of interest. Procedural algorithms are normal computer programs, algorithms, scanning the images, going through the pixels, looking for objects of interest. And AI machine learning models is the deep neural networks. I imagine the holy grail of this project will be good AI machine learning models at detecting flying craft and satellite imagery. And I look forward to the day where hopefully we can get images coming off the satellite and being processed automatically straight away, and all the flying objects being detected through any one of these methods really, and then getting notified about those objects so any one of us can jump in and have a look and see what's appearing. So I'll go into each one of these sections in a bit more detail. Um, Source imagery. This is the images coming off the satellite. If you're new to satellite imagery, it's not too overwhelming as it may first seem. If you have a few Googles, there's a lot of results out there, but basically there's only a few providers that will be of interest, and you learn the terminology fairly quickly. There is a great website I found linked at the top here, State of Satellite Imagery, which gives you an overview of the current state of the art, and those providers and what you can get out of them. This is a list of some providers. Obviously, free satellite imagery is of big interest because we can get that for free. Then you have your commercial providers like Maxar, which is Digital Globe, same thing. Not sure why they name differently, but Maxar, Digital Globe, same thing. Airbus is another one. Planet.com, that's a popular aggregator of satellite imagery. And then AWS Registry, Microsoft Planetary Computer. These are more platforms for accessing satellite imagery, which will have copies of the satellite imagery available, but there'll only be one source of it. So, for example, we'll talk a lot about Sentinel-2. That's actually the satellite here shown in the picture. That's from the European Space Agency. Sentinel-2 has two satellites, A and B, orbiting the Earth, and they provide 10-meter resolution imagery, and it's free. So 10-meter resolution, what does that mean? That means every pixel in the image is 10 meters. So if you had a house 20 meters long, it's only going to be 2 pixels in that picture. So that does sound pretty low resolution. You maybe you're used to Google Earth and Google Maps. You can zoom in and you get a much higher resolution. So you're probably wondering, why would I use that when I can get that off Google Earth? So we can speak a little bit about that and how that ties into satellite imagery. If I jump to Google Earth, and let's zoom in on a part of the world that doesn't maybe have the 3D buildings, just because we're interested in the imagery. Here's a town in Africa, and we can get in pretty close. All right, so we can see the individual cars. So this is about this is the highest res imagery you typically get off publicly available satellite imagery, commercial as well. You'll definitely be paying for this quality, and this is about the 30 centimeter, 50 centimeter range per pixel. So where does this image come from? Well, if you have a look in the bottom left, you can see this one is from Airbus. And if you pan around on Google Earth, you'll find often it's Airbus. If you go out far enough, it'll be NASA. But if you zoomed in on the low res stuff, it'll be Airbus or Maxar. And so Google gets their imagery from the same satellite providers that we have available to us. Of course, Google's only interested in the case of Google Earth, stitching together a base map to provide an image that's reasonably up to date, but it's only one single point in time. So what we're looking at here might be taken a few years ago, which isn't of much interest to us because we want to be scanning for flying objects in the sky, which could occur at any time. So the more frequent, the better. In terms of frequency, so I'll jump out of Google Earth. That's just tying in how what maybe you're familiar with satellite imagery and how it works. In terms of frequency, the Sentinel-2, 2 to 5 days revisit time for any land on Earth, which is as good as you get. If you go to the higher resolution, your Airbus and your Maxar, they have to prioritize their satellites because they obviously scanning a smaller region at higher resolution. Depending how much you pay, how much interest there is, how much that area will be scanned and how frequent the images will be coming off there. Maybe one other thing to speak about quickly is an introduction to satellite imagery. The bands. So bands are your wavelengths of light. If you remember from your high school physics, that's your, for example, your red, green, blue. So red, green, blue is using computers to divvy up the numbers, but all the colors of the rainbow basically. And then you can go above into your ultraviolets and below into your near infrared and lower and lower. The kind of bands that we get off a satellite image is not just the visual spectrum, so it's not just what we can see as humans with our eyes. It does go lower as well into the near infrared, and it tends to be quite a few bands below that as well. I'm not too familiar. I know with Sentinel-2 you get about a dozen bands off, including red, green, and blue, which make up the visual spectrum, and you get a bunch of infrared bands as well. And cloud cover is obviously a big concern. When you start looking at satellite imagery, you might be a bit disappointed that they might be obscured by clouds. Although, without what we're looking for, might be flying above the clouds. So not all hope is lost. I've put a link to EO browser in the right here. EO browser is one of many websites or tools you can use to browse satellite imagery. It's one of the better ones I've found in my testing over the last week, but there are many out there like it, and it's by no means set in stone as the one to use for this project. But it helps us get our heads around what the satellite imagery looks like, and I'll show how it can be used. So here we are looking at EO browser. I wanted to first focus in on an airport so we can see what a flying object looks like in the world, because that is one of the reasons I had this idea. Is flying objects have this artifact in the images where it makes them easier to detect. Even though this is 10-meter resolution, it's easier to detect flying objects because they have this artifact where it's kind of a ghosting effect where the red, green, and blue bands appear separated from each other, and I'll show you what I mean. So we've got Sentinel-2 that's selected by default. These other ones are quite a lot lower res, the Landsat, which won't be as useful to us. And I'll select the time range. I've selected the last week or last month, and I was zooming in on Gatwick Airport in the United Kingdom, which happens to be a hotspot for UFO sightings, at least it used to be. And we'll run a search. So here we can see the images covering those areas, and here as well you can see the clouds and these thumbnails of the images as well. I'll look for a clearer day because we are going to be looking for aircraft. There's a nice clear looking one over there, and let's zoom in on Gatwick again. Okay, I ran this one earlier, found the same plane. So on the left you can see it's selected true color, bands 4, 3, and 2, which are the red, green, blue bands, giving us the visual. You can choose other bands to show yourself. And another thing to mention, if you wanted to look at the images straight from the source, so we can download the Sentinel-2 images straight from the European Space Agency once you sign up, which is free. It's just an S3 bucket on Amazon. You get quite a complex image. It's not just your JPEG or your PNG. These are special geospatial images, so they obviously correlated to a specific part of Earth, and they have many bands. So it's not just red, green, and blue. You have all these bands to compete with. So you need to use a specialized application to view them. QGIS is the industry standard, and you can download that for free, and you can by all means have a play with that. But what I found with the EO browser, it's simplified it a lot for us. It's already stitched together the 3 bands of interest that we're interested in, or maybe we're interested in. Here's a one that's been optimized to make it a bit clearer, to show land, but again the visual spectrum. There are other bands here, such as well, you can read about it. There's a false color band, there's a moisture index band, there's infrared bands. I'll go back to the true color one because that's what I'm interested in, and you can see the effect here. You can see a planes on the runway either leaving or arriving, taking off or landing, and you can see the blue, green, red effect here I was talking about. And this is why I'm interested in using these images, because you can easily detect flying objects. Here's another one. We are at a busy airport, so we expect to see a few planes in the sky, and the hope is even at this 10-meter resolution we can detect these flying objects. You can kind of tell this is a plane from the shape, but even when we do find something that doesn't look like a plane, it's still a blurry photograph, right? It's not going to be hard proof. But for me, I certainly know for me that provides something quite interesting to then go and look more into. You can then go and look if there is any commercial imagery at a higher resolution at that around that time and around that place, and any other methods you can think of. Any other maybe you could pick up many incidents in a particular area of the world, for example, and then you can do other methods of monitoring the area. So because we have this imagery available, we can scan it, we can detect these objects of interest. Why not? I think it could provide some very interesting information if there are indeed any flying objects in our skies, which I'm sure there are. So that's a quick introduction to EO browser. I guess EO stands for Earth Observation. I will jump back to our slides. We've been looking at the source imagery. The first technique for processing the source imagery will be the visual processing, what I've called visual processing, which is just the human processing of the imagery to detect objects of interest. So panning around an image like we were, and looking ourselves for an object of interest. There are obviously 3 critical data points we want to take away, which is the source image, any object was located in, the time and the location. Once we have that recorded, we can go on to ID the object, add commentary, add metadata, capture thumbnails, all that fun stuff. I imagine in an early part of the project, this will be where most of the work is concentrated, because we're going to need existing objects labeled and tagged to test and train the algorithms and the machine learning models. On the right here, I've linked a interesting project, ship detection in satellite images from scratch. They've used the label me package to label the ships. So that's your bounding box around the object of interest. And that's the kind of thing we'll need to be doing early on as well to build up our data. The next technique is procedural algorithms. So this refers to the classical visual processing techniques to detect objects of interest. What I mean by classical, it's just an algorithm. It's just another computer program. It could be looping through the pixels in a procedural way to detect objects. There is a very good paper, promising paper, published, Creative Commons license, on detecting aircraft in Sentinel-2 imagery. That's linked here. They've published the algorithm, if you like. It's not the code. I couldn't find any code published along with the article. I will reach out to the authors to see if there is any such code, but it is the procedure and the maths behind how they detected planes with a high level of success, it seems. And not only the detection, but also the velocity of planes from Sentinel-2 imagery. I can imagine this can be implemented and adapted in our project, and I just know from my experience, when you have something like this, automating it won't be too hard. And how fun will it be when we have all the planes? That's a fun project in itself. Before we get to the unidentified objects, all the planes being detected automatically. I'm sure there might be others, other classical visual processing techniques that we can apply as well. I just highlighted this one because it's a good place to start. AI machine learning models. So this is I imagine where the project is going to go, and hopefully we get some really good models to automatically scan and detect these objects. Linked a GitHub repository here which lists a bunch of public techniques with deep learning and satellite imagery. Good place to start, I imagine. Also mentioned to Google Earth Engine. Google Earth Engine is a platform by Google to do just that, to run models on satellite imagery. They have all the satellite imagery on their servers, ready to be processed. You can add your script, so that provides us with compute. I wonder what level of compute we can use, but it looks like you get a lot for free. So it provides us with a platform to run our models on, potentially, and it provides us nice editor where you can see the map and the region and all this stuff to host your models in. Detections. This is the recording of detections we have made through any of the above techniques. Pretty standard in terms of a high-level architecture, database, API, and a website. And then we have also our workers, if you will, detecting and writing detections through the API to our database. For the database side of things, going to use Postgres with PostGIS. That's the geospatial extension to Postgres, and you can do all the geospatial fun things like detecting an object is within a polygon, for example, out of the box. And I will be focusing on getting a minimal solution in place initially of this, so we can have something in place to start recording any detections and start labeling through the visual processing methods any objects of interest and start using it. So the idea is everything is public, open, 100%, which is why one of the motives of this project to end the cover-up and do away with the secrecy. So viewing it will be public and open. Writing to it, of course, needs to be controlled, so we don't have any bad data going in there. So people looking to add data, join the project, be a research assistant, help out. Will just be a registration, and we'll just um, vet any writing that happens to cross-check it with um, other people or machines processing the same images and seeing they're coming up with similar results and comparing them. We can quickly see if anything is untoward. So that's it pretty much. In the next slide, we have some housekeeping. We have a GitHub. We've started an organization. We have a Driller board. So far, we have a weekly meeting on Sundays at 10 a.m. Eastern Standard Time if you're in the States, or whatever time that is wherever you are in the world. Join our Discord. You can see the event there, and that's where it will be hosted, and you can join like-minded people in the next one. Great, thanks. Hope to see you there. Bye.